Hello and welcome. In this tutorial, we're going to go from the Sefaira plugin on SketchUp to the main cloud-based Sefaira platform. And so in another tutorial, I took this model, this hypothetical five-story office building located in Indianapolis, and I introduced the Sefaira plugin for SketchUp. We went through the energy analysis, we went through the daylighting analysis, and we discussed on there how all these different dials and figures add value to a quick iterative design process. We examined how to look at the thermal properties of the model in this plugin, how to check your entity palette. What we're going to do here now is do a quick retread over the quality control measures to make sure everything's okay. And then we're going to upload this model to the main cloud-based Sefaira online platform. So, uh, as usual, we've got our very planar-based model. The fewer surfaces, the better. I want to go through via the plugin and check my entity palette, make sure that everything is correct. So let's run through that. My roof is looking okay. Actually, let me back out of this. I need to click here, show entity type. There we go. That's going to be more useful for us. Um, Again, check the roof. Looks good. Check my opaque wall. Or I'm sorry, this is my floor. My floor looks okay. This would be my walls, my opaque walls. Notice penthouse included. Okay. Shade. I don't have any shade structures in the model at current. Uh, in another tutorial, I showed how you could assign some surfaces as shading, including adjacent structures that may be obstructing solar access. Make sure you have fixed glazing differentiated from operable glazing. That will matter because operable, there is an assumption built into the energy analysis that occupants will use it for natural ventilation. Interior walls, my internal or has interior walls. They're adiabatic, which means they're thermally inconsequential, but they are still needed for daylighting. Take a look at internal glazing. I have no internal glazed surfaces and no surfaces to ignore. So my entities look good. I can hide that. Um, in the other tutorial in which I introduced the Sapphire plugin and I went through all the items you see here in the plugin. I did express some reservations about the EUI, the energy use intensity. I felt like 34 was really good. Not as good as our targets for the 2030 challenge, but 34 is pretty good. Of standard average office building in Indianapolis, you would expect something closer to 90. While I started off with certain baseline assumptions for 90.1 2007, which is what the energy code is for Indiana, which is where Indianapolis is located. I did dial things around a little bit, but I still feel like 34 is really, really good, probably too good. I trust the online platform better. You'll see there's just a lot more to choose from in terms of options, details, really understanding what it is that you're assessing from a enclosure standpoint, mechanical standpoint. So let's go ahead and jump there. I first like to just update the analysis in the plugin, make sure that everything works correctly. It'll perhaps adjust this a bit. It'll at least refresh. It's doing an Energy Plus analysis right now. Okay, everything's fine. I am going to hit this blue button right here, upload to Sefaira. And model has successfully uploaded. That's a good thing. Your model is ready, is what you want that to say. Hit continue to Sefaira. Okay. And I'm going to start a new web app project. I will call this um, example Indianapolis office building. It's got my address. It's going to geolocate the project and draw off of the climate data you see here. So that's 6 miles away from where it's citing me, presumably in the middle of the city. I could take Eagle Creek Airport, a couple other locations. These start to get well outside of Indianapolis. I'm going to stick with the airport and look at the building type, just like what we plug in. There are very few building types you can select from. I'm going to stick with office. That's the most appropriate in my case. Space use, I'll give you these plugin defaults. You can choose from a selection there as well, though I typically advise just leaving that as it is. Hit create new project, and it's going to pull this project in, and good. Looks like everything's loading. So it's going to immediately start simulating your baseline concept. It's going to start to populate, as you see here, some of the performance results. Right off the bat, you'll notice HVAC system type. It's going to give you a system right out of the gate. In the case here, a variable air volume, return air package, system 5 and 6 per ASHRAE, and that's where we are starting. And you'll see an EUI here that's looking a bit more reasonable compared to what the plugin had. So this is why I have a lot more confidence with what's occurring in the main online Sefaira platform. And you can see these other figures listed here. I find this one useful when you're looking at different energy conservation measures, understanding what the overall energy cost would be. That's drawing off of the units of energy, the different energy sources for your project. Is it using electricity? Is it using natural gas? It's going to be pulling in some uh, cost data for that as well. And you see these tabs, and you have this envelope tab, a shading tab, space use tab, airside mechanical, waterside mechanical, natural ventilation. If you have on-site solar, that's there too, and then zoning. I'm actually going to start with zoning, where you can see here, if you're familiar with the ASHRAE handbook, standard default definitions for zones within a floor plate, you'll see that this is a pretty much in accordance with that. You can see these zones identified. It's going to do this for every floor of your model. And it's good to go through and check this, make sure that it is all proper. You can actually change the space use tab values. I could go with a different space use type. Maybe you've got a project where the first floor is commercial and the rest are residential that are above, and you could define that. Whatever you need to do, this will give you that flexibility. Your zone depth off the perimeter set to 15. You can change that as well. There's some different zoning strategies that you can employ. Again, this is just the basic perimeter slash core approach, which is brought in by default. And with that, I am going to, by the way, you can actually take these individual zones and adjust them accordingly. So I'm actually going to now go back to envelope, and within this tab, I'm going to draw your attention first to building orientation, by which it has this A, B, C, and D. You could think of it as the north face, east, south, and west, but my building is rotated 45 degrees. And so I can actually rotate the building if I so choose. This building rotation, I could uh, set this, I could rotate the building to a certain degree. Will it matter? Who knows? Well, there is a way to know. I could arbitrarily dial it one way or another, but I could also hit this icon, this blue and red icon. This is to generate a response curve. This is to look at the building. You could take any parameter that's in Sefaira and you see these tabs. You can start to, in these response curves, you can, I'll get into this in just a second, but this response curve tool can be applied to any of these. You want to select uh, what metrics you want to examine, how they might change as the building rotation changes, and you can select up to two. I will just pick EUI for now, and let's see if EUI changes as the building orientation changes. So I'm going to do a 5-step approach between rotating the building 180 degrees one direction versus another, and you can hit run simulation, and it will now run 5 different iterations of the Energy Plus model, incorporating sort of evenly distributed check on that rotation, and you can see here this response curve that the building's actually pretty optimal in terms of its rotation. I could rotate it a bit. I'm going to start to lose a little bit, but also, while this looks like a really severe curve, look over here to the left. We're not talking a lot. We're talking the difference between 56.5 UI and 56.1. So look at the curve, but also look at the axis, look at the values, and sometimes the curve can be a bit deceiving if you're not being mindful of how many units we're talking. So I'm going to leave the building rotated as it is. You look at things like wall insulation. We've got our R value of R20. This is assuming a concrete block structure. I'll go ahead and leave that. You see here, there's few different a few different options you could pick from. This assembly R value of 20. Would that make a big difference? I could run a response curve there. Let's look at facade glazing, where the assembly U value is set to 0.34 as the total assembly, solar heat gain coefficient for the glazing being 0.4. And that's for the assembly average as well. I could break this down into a different value set per orientation. So to go back to that north, south, east, west orientation designated with the well, if you A for north, C for south, B for east, D for west, I could look for any one of those orientations. Because my building is rotated, my, let's say, north face actually is being associated with both the northwest and northeast faces, and that the south face isn't really present. We're looking at D being associated with the southwest and B being associated with the southeast facing parts of my building. So just keep that in mind. Look at the graphic symbol here to understand what it is you're doing. If you don't want to adjust a parameter on a per face basis, you can go back up here and you see, unlike this icon, now it's a different icon. The solid rectangle is to look at the entire building. So I'm going to leave that here. And let's look at the assembly U value response curve and see what we might get. Let's again stick with a 5-step analysis: an extremely unrealistically good U value and an extremely unrealistically bad U value on the assembly. And let's just see what we would get just to create a colorful example here. And we hit the button to generate the response curve, and hopefully Sefaira cooperates. And oh, I forgot to select an input. So that can happen at times. Let's go here, select my EUI, and there you go. You can see the response curve that yes, as my U factor gets better, the building performance improves. You see up here, it actually starts to change trajectory a little bit. But again, this is not compelling enough for me to want to change my entire glazing system at this time. So I'm going to leave that where it is. What about down here? We have things like infiltration. Just looking at 75 pascals. You could look at your design infiltration here at just around 0.6. I'm going to look at this as well. Let's assume we went from something that is extremely airtight to something that is very much not, and run a response curve on that. Let's see what the impact would be. Again, I'm going to stick with the EUI. Our simulation. And this is going to give us from essentially something that's very, very good, like we're talking getting into the passive house territory on one end, and then being a very leaky building on the other end. And we can see that, yes, as our building becomes more airtight, our EUI does improve significantly. So the more airtight, the better. That's good to know. That is consistent with what one would expect. I do think this design of air infiltration rate for the baseline concept, standard conditions, I think this is maybe a little bit generous. I'm going to actually tip this, whoops, to 0.8. I think that's maybe better for what we would expect at 75 pascals. And I don't have skylights. If I did, the roof glazing would matter. My metal deck assembly R value just over R20. Okay, so that's the envelope. You can also look at these custom inputs. identify if a project is residential or non-residential. We're set to non-residential. Uh, Based on the SketchUp model that was imported, my glazing, my window to wall ratio is 0.38. I can actually turn this on and adjust that globally. It will override what was imported from SketchUp. So if you want to do that, you can turn this on. You can do it globally for the entire project. You can also adjust it face by face and go to shading. The building did not have any shading on the glazing, and by default, it's going to say analyze shading drawn in the three-dimensional model. So what you identified as a shading surface in SketchUp will have been imported. I have none in this example. To flip back over, there's no surfaces identified as shading that's protecting the glazing at all. I can use this tool to start to examine this, and they can look at it on a per face basis. So let's say my south-facing surfaces, that would be D and B. Maybe they have some kind of treatment. Let's just take B, for instance. I can select B. I can look at horizontal shading, vertical shading. You could assume automatic blinds. There's a lot of options here. For my baseline, everybody, I'm going to leave this off. Space use. This is where we get into design loads, temperature set points, HVAC schedules, ventilation, outside air information. Uh, this is where you can really start to adjust like your scheduling, how the building's being occupied. There's a lot to dial through here. I mean, you can go in and fine tune your thermostat set points, see the impact of that, your lighting power density, equipment power density, the occupant density, the square footage per person. And so that's useful information to have as well. You can look at your airside, package rooftop unit, coefficient of performance. You can adjust the heating coil source. Is it electric? Is it water? Is it gas? Is there one? You could have an economizer strategy, have no economizer. I think in my default building, perhaps I have no economizer, and you can go to some advanced settings, look at peak specific fan power. I'm going to leave that alone. Zone terminal units. I've got a VAV system, again, noting up here. So a VAV box, you could do a fan powered VAV box if you wanted. A heating type, you can specify what the source is for that. You get the minimum turn down ratio over primary air fraction if you feel so inclined to adjust that. On the water side, based on the system you have configured, and in the case here, I have a heating hot water loop. It's gas fired. I could make that all electric and see what the impact of that would be. I'm going to leave it gas for default. It's got my boiler efficiency slash coefficient of performance, peak distribution energy, hot water temperature. You can set that as well if you really need to fine tune that. I will say that Sefaira will give you reasonable defaults out of the gate. So if you don't feel compelled to change anything, I would not start randomly dialing stuff up and down. Natural ventilation. I do not have a naturally ventilated office building right now. I could turn that on if I wanted. I don't, in my baseline model, I don't have solar panels, so I'm going to leave PV off. I have already talked about zoning. Okay, so I'm going to go back to envelope. I'm going to hit update. It's going to refresh this. Most likely this EUI number is going to increase, but I think that what I've developed here is going to be a better baseline concept. So I think the inputs are more akin to what I would expect to see. This I did go up just a little bit, 59. I'm feeling better about this baseline concept. I could go to energy breakdown over here and get a sense of how the building is likely to perform. I can look at this in this annual pie chart. I can break this down on a monthly basis. It's going to tell you the heating, cooling, interior loads, fans, other gas listed here. So this is interesting. As you develop other concepts, you can start to compare them. You can download the information. This starts to give you some really good info. You can go to plant sizing. This will give you some basic information on the mechanical systems. This is useful with your mechanical engineers. This is going to be some information that's going to really help you start to adjust, especially at schematic design. design development, as you're really looking at different energy conservation measures, this is going to allow you to get into that next level of information. I'm going to collapse these sub menu items. And what I would like to do is now show you how to work on a couple of examples of strategies, energy conservation measures, just hypothetically, so you can get a sense of how the options work. So I've got my baseline. You can hit this here to actually copy your active baseline. It's going to now copy it down. I've got clone of baseline. I can select that. It'll make it larger. The larger highlighted concept is the one that you're currently designing in. So I'm going to leave my HVAC system type. Um, I think here what I'll do is let's go ahead and call this something different. I'm going to say, maybe we call this, and I'm going to say concept envelope improvements. Okay, so I'm going to go to my envelope. Let's just assume that my assembly U value now I'm working in this concept. I'm going to say maybe we can squeeze this down to 3. Maybe my notice it immediately said, hey, you need to update this. You've changed some things. Simply R value, let's say we can up this to R26. Infiltration, let's say we can actually improve our infiltration to 0.5 CFM per square foot. And my roof insulation, let's just go with a R30 roof. So we just made a tighter, better insulated enclosure. I'm going to go to shading and actually let's go ahead and for I'm going to say for the south facing faces. So for D and B, I'm going to say we're going to have horizontal shading. And so you can dial this up. I'm going to, that's just become a bit much. Let's just put it at 0.5. B, let's also make this 0.5. So I've got shading on my two, horizontal shading on my two southward facing surfaces. And I'm going to go back here to total, and let's just say that I'm going to have automatic blinds and shades, and let's say at their internal Venetian blinds for everybody. And okay, I am now going to hit update, and it's going to take these envelope and shading improvements, and it's going to incorporate it into the design. Now, what's interesting is sometimes when you have compounded efficiency measures, it doesn't necessarily result in an improved outcome. In this case, it did. Felt pretty good about that going in. This is a discovery process, though. When you use something like Sefaira as a tool, sometimes you'll see outcomes you don't expect, where you start to shift the fuel source that you're using. You start to adjust things in some ways where you get some results you weren't quite expecting. You can see here, this would actually save the owner of the project about 9% on power, and we reduced our EUI by 13%. I'm interested in carbon too, so I'm going to go to cooling equipment here, and I'm going to change this actually to look at annual net CO2 equivalent emissions, and you can pick that, and it gives me that in pounds. You could also, as you saw in there, make it on a per area basis. So if my baseline is 23, I'm now down to 20. Okay, notice it's pounds per square foot. So it's keeping with my IP units. It's none of that kilograms mixed in with feet squared. It should be kilograms per square meter or pounds per square foot. So always watch your units. So I'm going to actually, I'm going to build upon this. I'm actually going to call this, maybe I'm going to call it in shading. And let's go ahead and call it concept A so that I can clone this and say, okay, I'm duplicating concept A, all those improvements I made. Now I highlighted it. It's now the active concept. I'm going to make this concept B. And so I'm going to call that A plus, and let's say natural ventilation. Okay, so I'm going to do that. So I've got everything from A highlighted and duplicated down to here. I'm going to make this A plus natural ventilation. Let's go to natural ventilation. Let's activate this. Okay, I'm going to assume my building automation system can help occupants manage an HVAC integration. And I'm going to leave these defaults in here, commercial ventilation, mechanical ventilation unit on during occupied hours, openness, 100% of glazing area. That might be a bit much. Let's go with 50%, free percentage of opening, free area percentage of opening 50. I'm going to tamp that down just a touch. And if building is unoccupied, all openings closed. That's not a bad default. If it's windy, all openings closed. That's also pretty safe. Okay, so let's do that. And so here I also went to this side menu and hit the comfort tab. Enable thermal comfort will increase simulation time. So I'm gonna say I'm okay with this. You could go a little bit deeper into looking at some of the comfort criteria. And I am going to hit update and let's see what concept B will offer. Noticing that simulation is going to take longer with the thermal comfort information activated. We'll see just how much longer. It's starting to load and wait for this to come through. Notice relative to the baseline concept up here, you have this other information. You can imagine a situation where you have a growing list of different concepts, different combinations of energy conservation measures that you're using on a project. So this will keep loading here. It's going to take a while. It's giving me that additional comfort information, which is useful. While it's doing that, I'm going to give it a few more seconds here to see if it will come through. There it goes. Okay. So this is giving me some additional information. This is what I was hoping for. So drivable comfort criteria, 15 zones. Notice each one of these shapes are zones. 15 zones in the project have failed across the 5 floors. And it's going to help you go through and examine that. So you can start to look at the color scale. I can go with a gradient scale too. I'm going to keep it to the 4 color scale. And you can really go through and start to get a sense of thermal zones that pass and others that actually don't. So I'm not going to go into this so deeply now to keep this thing manageable. You could go over here to ASHRAE standard 55 using predicted mean vote. And this is going to give you, again, some information, may be useful. But up here at the top, this predicted mean vote is looking at between negative 0.5 and positive 0.5. It goes to -3 and +3. So this is not too bad. That's actually keeping within that band of the PMV scale is pretty good. So you can go in and examine a lot of this information. Operative temperature, also some information you can look at as well. So take some time if you feel so inclined to examine that. I'd like to go up here to concept B now. By allowing for natural ventilation, we've cut down the EY even further. I'm going to just do one more of these now. I'm going to clone this and go down here, call this one concept C. This will be my last one for this example. So we'll call this concept C, A plus B plus PV. I'm going to add some PV here and show you how that works. And I'll actually, we're on comfort. So then turn off the thermal comfort information. I am going to go to my PV. Now my roof, if I flip back over to SketchUp, if I select this entity, look at my entity info, I've got about 10,000 square feet. I'm not going to be able to utilize all of that for PV. If I'm lucky, maybe I could use 7,500 square feet. So if I go over here to PV, I look at the panel area, whoops, let's just go with 7,500, select that, and panel tilt. Let's say it's got a little bit of a tilt to it. Actually, this is a perfect place to use my PV panel tilt. So that would be 0 being a flat horizontal, 90 be straight vertical. Let's run the simulation. And let's see what the optimal orientation of my solar panels could be. Notice my PV panel efficiency, 14%. PV panel orientation, that could matter as well. Let's turn on my EUI. Oops, did not select it there. Oh, I did select it there. In simulation, not sure why that did not operate. Let's see if this works this time. Panel orientation. Actually think that this is another one to look at. Okay, so I'm getting some issues here where some things are not activating. So okay, every once in a while you get a little bit of issue here with some of these analyses. So forget that one for a second. Okay, I do every once in a while find the response curves get a little clunky and crash a little bit. So don't let that throw you off if that occurs. Um, Panel orientation, I'm going to keep them facing towards the south, put that at 0. And I think I'm going to just leave it at a 15-degree tilt. And for the sake of this analysis, I may want to, close out my browser, log back on later, refresh, and perhaps those response curves would work. But for now, I know that based on my available area, if I had rooftop, especially considering the obstruction of the penthouse, this might even be less. I might even be just looking at maybe a 6,000 panel area, 6,000 square feet. So uh, I've now got my concept A plus B plus the on-site PV, and I think we're ready to update this. So let's go. Let's see what happens now with these envelope improvements. Increase the tightness and insulation values. We enabled some natural ventilation at a reasonable level, and now we're adding some on-site solar to the roof. And on balance, what this will mean for my project is, drum roll, an EUI down to 35 from starting at 59. By the way, when you look at these numbers, I like to highlight the baseline because then it gives you numbers relative to the baseline. So what we've done here with concept C is we have reduced the annual net uh, CO2 equivalent emissions on a per area basis by 47%, which is pretty solid. The EY, we've gone from just around the 60 mark down to the mid 30s. So went from 59 to 35, a 40% decrease, also good. And on our annual energy cost, went from something in the ballpark of 59,184 down to 38,688, a 34% decrease. And you could look again at your energy breakdown, start to understand how the building is using it. You can do a monthly breakdown. You can look at everything on a cost basis because we still have mixed uh, sources. We have electric and gas. You could also look at your CO2 equivalent emissions, excluding renewables, and see what that looks like as well. So I hope that this is a helpful introduction to Sefaira and you feel comfortable jumping in, and good luck iterating, and thank you all for your time.